Hello, my name is Ivan from Cisco Tech. This video shows general troubleshooting tips for collecting additional information for a memory leak problem. When dealing with high memory usage problems, typically you see a log message indicating that the warning limit of 85% has been reached. These values varies depending on the version. Different logs are generated depending on where the system found the problem. Log improvements are available from version 16, 12, and later. Information tag needs for initial triage. We need these commands output. In case of an unexpected reload due to a low memory condition, we need the core file, the system report, and graph of memory utilization over time. Attaching a show tag is desirable. It is helpful for tag, and you can benefit from the automation tag has developed to help you find issues faster. Conditions leading to a high memory utilization are always software related. However, not all instances of high memory usage are unexpected. It is important to understand the available DRAM and the mix of features running on the device. Make sure you are running a supported version. Look for the end of sale and end of life document for the release. If needed, move to a version that is currently under software maintenance releases. Otherwise, tag can be limited on the troubleshooting and resolution options. For a complete document around memory troubleshooting, you can refer to these guides for the ASR 4K and ASR 1K devices. In Cisco IOXXE routers, DRAM is one of the most important resources that support core functionality. DRAM is employed to store different data types and processes features information that are essential for both the control plane and the data plane operations. Main uses of DRAM in IOXXE routers include IOSD memory, QFP memory, temporary file system, and general processes running on the Linux kernel. High memory utilization of greater than 85% typically indicates significant DRAM consumption, which can impact router performance. This elevated usage can be a result from legitimate demands, such as storing extensive routing tables or enabling resource-intensive features. However, it can also signal issues like inefficient memory management by certain features or memory leaks, where memory is not properly released back to the system after use. By monitoring memory utilization across IOSD memory, QFP, TMPFS, and general Linux processes, you and TAC can identify potential problems earlier. For memory troubleshooting, TAC needs to collect a set of commands over a period of time to identify the offending process. Sometimes, after the culprit process is identified, additional specific commands are needed, making memory troubleshooting one of the most time-consuming types of troubleshooting. In order to make this troubleshooting easier, you can use the EEM feature to monitor and automatically collect information. There are two main considerations for writing the EEM script: trigger, and commands to be collected. Triggers, pattern. You can use the pattern as trigger with this command within the script, even syslog pattern. One of the considerations while using a pattern as a trigger is that the log is generated once the warning threshold is reached. Depending on the memory consumption rate, trying to do it manually, you or TAC do not have enough time for a more detailed troubleshooting. Cron timer. Example of a cron timer to be activated every 30 minutes is given here. Reference of cron syntax for different monitoring periods is minute, hour, day of month, weekday. There are many examples over the web. One of the advantages of cron timer over pattern is that you do not need to wait until the device almost run out of memory resources to collect the information. Depending on the memory consumption rate, with proper monitoring and information, TAC can identify the offending process before reaching warning threshold. Note that Rate limit and max run options are used to guarantee that the entire set of outputs are collected. They also help to avoid additional noise or EEM activation in situations where multiple logs appear in a short period of time. EEM examples: syslog pattern match base, monitored daily with a cron timer. EEM example scripts are documented in the article Report Problems of Memory Utilization via EEM. The link is provided in the description of this video. When the memory utilization reaches a critical level, chances are that the operating system forces a crash in order to recover from this condition, generating a system report which contains a core file. The core file is the full dump of memory for a particular process that crashed at certain point in time. This core file is critical for TAC to inspect memory and analyze source code to understand the conditions and potential reasons of the unexpected reload or crash of the process. The core file helps TAC and developers to find the root cause of the problem, debug, and fix the issue. Note that even though TAC and developers strive for getting a root cause, there are times when the crash was a consequence of a network event or a timing issue, which makes it virtually impossible to reproduce it in the lab. For more information about unexpected reloads and how to retrieve a core file, refer to Troubleshoot Unexpected Reloads in Cisco iOS platforms with TAC. Thank you for watching.